Very good morning to Anata present here. So today we are going to have a topic on pure substance. Before moving to the presentation, let us have learning objectives. So what is meant by a pure substance? What are the phase of mixture, say homogeneous and heterogeneous mixture, and identification of different properties of pure substance, say solid, liquid, and gaseous matter. Now we will go with the main theme of presentation. So what exactly the pure substance? What are the common information that can be noted in pure substance from thermodynamics point of view? So generally speaking, pure substance, you take water uh, as a best example, which is considered to be a homogeneous in nature, which has only one common uh, atom, a single type of an atom or a molecule, which is considered to be homogeneous throughout the state and uniform composition. The substance has fixed boiling point and melting point temperature. These are the common identities to refer uh, the pure substance in general existence. Now let us see what are the different phases of pure substance. There are three primary the phases as given here: solid, liquid, and gaseous phases. But each may have differ with respect to the identicality in general. So let us go with the solid phase. So the atom, the molecule bonding form a closed chain link and it is strongly packed within a three-dimensional crystal. Molecules do not move relative with each other since due to the tight packed nature within a three-dimensional crystal. And next one is intermediate molecular bond strength in liquid phase. So liquid molecular phase have considerable spacing compared to the solid phase. The molecules will free float in group. So a lot of void space gap between every molecule. So it allows the molecule to free float in nature. Whereas in gaseous phase, so each molecule will have weak bond strength and the gas molecules are separated by its distance far apart and they don't have well-ordered structure like solid phase, and all the molecules will transition randomly and it will collide with each other. So the previous slide which tells about the physical reference of solid, liquid and gaseous phase in pure substance. Now you are going to see about the phase change process of a pure substance. Let us examine a compressible liquid. We take a water available at a room temperature 20 degrees Celsius and a normal atmospheric pressure, 1 atmospheric pressure, which is tightly sealed inside a piston cylinder device. So initially the water is in liquid state. So it is otherwise called as a compressible liquid or subcooled liquid. So in the next stage, by adding little amount of heat to the compressible liquid, the fluid temperature rises to 50 degrees Celsius. From 20, it rises to 50 degrees Celsius. Due to that, the volume of matter increases due to the addition of heat. So the piston moves slightly upward. Therefore, we can maintain a constant pressure inside the cylinder. The next segment, further heat is continue to increase up to 100 degrees Celsius, from 50 to 100 degrees Celsius. So the water begins to gradually turn out into vapor. At this point, we call it as a saturated liquid point. Still, volume undergoes changing, but the pressure will be kept constant. The next segment, from 100 degrees Celsius further, the heat is added to the water. Say, for example, from 100 to 200 degrees Celsius, you are heating the vapor. So more and more amount of vapor is continued to generate at a constant pressure. So this state we call it as a saturated vapor. The state between the saturated vapor and saturated liquid we call as an intermediate compound, saturated liquid vapor mixture. After forming saturated vapor, further any addition of heat will increase the temperature of the vapor, and finally we call that state as superheated vapor. So these five transition states can be expressed with the help of the temperature volume, the TV diagram, as illustrated here in the present slide. So y-axis represents different temperature gradient point, and x-axis represents the specific volume of a of water. So here the temperature volume diagram represents the phase change of water at a constant pressure. We say 1, 2, process 1, 2. It is in the form of compressible liquid, subcooled liquid. Then 2 to 3, it's a saturated vapor at 100 degrees Celsius. Till up to 3 to 4, the same state continues to occur. Then 4 to 5, after completely forming the vapor, so 4 to 5. So when you increase the temperature from 100 to 300 degrees Celsius, then saturated vapor mixture converts into superheated vapor at a constant pressure, say 1 atmospheric pressure. So here, the volume interchanges at each and every stage by keeping the pressure, temperature as constant. So what are the outcome of this presentation about a pure substance in engineering thermodynamics? So any physical form of matter can be broadly classified into two categories. Say pure substance and mixtures. The pure substance represents a specific form of a matter that has certain composition at a constant level and also standard properties that remain constant throughout the sample. So this is all about the outcome of pure substance. So once again, I thank each and every one of you for supporting the channel. So kindly forward these topics to your neighbor, the close neighbor friends. So thank you one and all present here. The next meeting we will see some other remaining topics left out in engineering thermodynamics, which is said to be covered in the future sessions. Once again, I thank all of you.